Hello everyone, welcome to the lecture again. In the last class, we look at various examples of the frictional forces. Today, we are going to study the force which are acting between the frictional surface and a flexible body, for example, the rope and belt. So, we are looking at the forces which are acting between a frictional surface and a flexible body, for example, some ropes and belt. We can have a situation wherein there is a peg and by this peg a weight W is held by a rope and by applying a force P. So, we have a circular peg and weight W is held by applying a force P using some rope. And the second situation can be wherein you have some circular disc or circular drum, and on this there is a belt, and by applying tension T1 and T2 there is a impending motion. Let us say the impending motion of the belt is in the clockwise direction. So, therefore, T2 will be larger than T1. Okay. So, we assume here that the impending motion of the belt is in clockwise direction. Therefore, T2 must be larger than T1, and we are going to analyze this case under this assumption. We can also have T1 larger than T2. In that case, the motion will be in the anti-clockwise direction. Now, to find out the equilibrium condition, let us look at a part of this belt. So, let us say this is the part of this. Let us say this angle is d theta, and because of that the normal force is N from the center is going to act outward. Since it is d theta, let us call it dN, and on this direction let us say the tension is T, and in this direction therefore, the tension will be T plus dt, because we have assumed that T2 is larger than T1. So, therefore, it will be T plus dt. Now, let us look at the angles. This angle will be d theta by 2. Let us see why. We have this angle as d theta, this is the belt. Let us draw a perpendicular. Therefore, this angle will be pi minus d theta, and we have to find out how much is this angle. This angle will be equal to that angle. Let us say this is x, this is x. So, we have x plus pi minus d theta should be equal to 180 degree equal to pi. So, this gives you pi will get cancelled, you get 2x equal to d theta. Therefore, x will be d theta divided by 2. Now, we can balance the forces in the x and y direction. So, the forces which are acting in the x direction will be t plus dt cos d theta by 2, and in this direction we will have t cos d theta by 2. Note that this drum is rotating in the clockwise direction, therefore, there will be a frictional force in the opposite direction. So, there will be a force mu times dn which is going to act in the minus x direction. Now, let us balance the forces along the x and y direction. So, summation fx equal to 0, this will give you t cos d theta by 2 plus mu dn equal to t plus dt cos d theta by 2, and cos d theta by 2 into t will get cancelled with this one. So, we have mu dn equal to dt cos d theta by 2. Now, we also know that for small d theta, cos d theta by 2 or d theta, that will be 1. Therefore, we have mu dn equal to dt. Let us call it equation number 1. Now, let us balance the force in the y direction. So, in the y direction we have summation Fy equal to 0. In the y direction we have dn force, and that will be equal to t sin d theta by 2 plus t plus dt sin d theta by 2. Therefore, we have dn equal to 2t sin d theta by 2 plus dt sin d theta by 2. Now, we also know that for small d theta, sin theta becomes theta. So, therefore, sin d theta by 2 will be d theta by 2, and therefore, here I have dt term and I have d theta term, and both are very small. Therefore, its multiplication will be even smaller. Therefore, we can neglect this, and we have dn equal to 2t into d theta by 2 or dn equal to t d theta. Let us call it equation number 2. Note that equation number 1 was mu dn equal to dt. So, let me just write it down, mu dn equal to dt. This was our equation number 1. From equation number 1 and 2, I can get rid of dn. So, let us divide 1 by 2. So, we have mu equal to dt over t d theta, or mu d theta equal to 1 by t dt, and this equation I can integrate over the angle. So, let us integrate between the limit. So, let us say corresponding limit. So, we have integral. Let us say the belt makes an angle beta. So, let us say this angle is beta. Therefore, the integral will be from 0 to beta mu d theta equal to, we already know the limit on the tension, it start from T1 to T2. So, T1 to T2 dt over t, this gives me mu, and d theta here is beta, okay, the integral of d theta is beta equal to ln T2 divided by T1, or e to the power mu beta equal to T2 over T1, or we get T2 equal to T1 e to the power mu beta. Note that in this derivation we have assumed that T2 is larger than T1. So, this is also very important point, that this derivation is for T2 larger than T1. Now, herein we have assumed that the motion is impending. If there is a motion, in that case instead of mu you will assume the kinetic friction. So, therefore, it will be mu k. Now, let us look at two very important points about this formula. Number one, theta here is in radian, and another important point is in this formula the radius of the drum has not come into picture. Therefore, this equation is independent of r, and therefore, it is not restricted to circular contact only, and in fact it can be used for arbitrary shape or arbitrary shaped surface. With this very basic concept, now let us look at the examples. So, the first problem statement is following. The 80 kg tree surgeon lowers himself with the rope over a horizontal limb of the tree. If the coefficient of friction between the rope and the limb is 0.60, compute the force which the man must exert on the rope to let himself down slowly. Okay. So, the situation is following. So, this is the branch of the tree, and there is this man. So, he applies the tension. So, let us say this is tension T1 and this one is tension T2 to lower himself down. So, we can use the formula T2 equal to T1 e to the power mu beta, where mu is the frictional coefficient and beta is the angle that the rope is making with the branch in radian. Okay. So, again let me emphasize here that T2 is larger than T1. So, T2 will be T1 e to the power mu is 0.6 into beta. Okay. Beta is the angle. You can see from the figure that the angle that it is making is pi. Therefore, T2 will be e to the power 0.6 pi, we can find out it is 6.586 into T1. Let us call it equation number 1, and now let us balance the forces in the y direction. So, we have T1 plus T2 equal to the weight of the object. So, here in person, so its weight is 80 kg. So, 80 into g 9.81. So, therefore, T1 plus T2 will be 80 into 9.81, and we can put the value of T2 from equation number 1. So, 6.586 T1 plus T1 equal to 80 into 9.81. This gives you T1 equal to 80 into 9.81 divided by 7.586, and which will be 103.45 Newton. Now let us look at another problem on the same concept, and the problem statement is following. The block of weight W is supported by a rope that is wrapped one end 1/2 times around the circular peg. Determine the range of values of P for which the block remains at rest, and it is given that the coefficient of static friction between the rope and the peg is 0.2. So, again we have this peg and we have the weight W, and we have the force P. So, let me write down T2 equal to T1 e to the power mu beta. So, T2 will be T1 e to the power mu is given, it is 0.2, and beta is also given, it is 3 pi, because it is wrapped 1 and 1/2 times. So, therefore, T2 will be 6.59 T1. Let us call it equation number 1. Now, let us first find out the largest value of P. So, if we are looking at the largest value of P, in that case you can think that the impending motion of the block is upward, because P is largest. So, therefore, for largest value of P, the block will be on the verge of moving upward. Okay. So, therefore, whatever is the largest value, that has to be T2. So, in this case T1 will be W and T2 will be P. Let us put that in equation number 1. So, we have P equal to 6.59 W. Let us call it equation number A. Now, let us look at the smallest value of P. In that case, you can think as if the impending motion of the block is downward. So, for a smallest value of P, the impending motion of the block will be downward. So, therefore, in this case now T1 will become P and T2 will become W. Let us put that in 1 again. So, we get W equal to 6.59 P or P equal to 0.152 W. Let us call it equation number B, and from A and B we get that P should be between 6.59 W and 0.152 W. Therefore, the block will be in rest if P is in this range. Now, let us look at one more problem on the same concept, and the problem statement is following. a flexible cable which supports the 100 kg load is passed over a flexible circular drum and subjected to a force P to maintain equilibrium the coefficient of static friction mu between the cable and the fixed drum is 0.30, then A for alpha equal to 0 determine the maximum and minimum values which P may have in order not to raise or lower the load, and B is for P equal to 500 Newton determine the minimum value which the angle alpha may have before the load begins to slip. So, let us look at part A. So, we have a drum and with this 100 kg mass is suspended and it is held by a force P and this angle is alpha. So, initially it is given that alpha is equal to 0. To find out the maximum value of P, let us say that the motion of the block is upward. So, for impending upward motion of the load, so we will use T2 equal to T1 e to the power mu times beta, and here my T2 will be P. Let us say this is P max equal to T1, T1 is 100 into G, so that becomes 981, e to the power mu is given 0.3 and beta, because alpha is 0, this becomes pi by 2. So, therefore, P max becomes 1572 Newton. Now, if the impending motion of the block is downward, in that case T2 becomes 100 kg. Okay. So, for impending downward motion of the load, we have T2 equal to T1 e to the power mu beta. T2 will be 100 kg. So, 100 into 9.81, which becomes 981 equal to T1 becomes P, let us say it is P min into e to the power mu into beta. Therefore, we have P min equal to 981 divided by e to the power 0.3 into pi by 2, and this comes out to be 612 Newton. Now, in the second part, it is given that P is equal to 500 Newton and we have to find out the angle alpha for which the load begins to slip. So, that means the load is larger than P. Okay. So, therefore, T2 will be 100 kg. Okay. So, let me write down part B, the load begins to slip and it is given that P is equal to 500 Newton and we have to find out what is alpha. So, T2 will be W, which is 981 Newton, and T1 will be P, which is 500 Newton. So, therefore, again T2 equal to T1 e to the power mu beta. From here we have 981 equal to 500 into e to the power mu is 0.3, and let us say the entire angle that it is making is beta. Okay. So, we can find out what is beta. Beta will be 1 over 0.3 ln 981 divided by 500, and this comes out to be 2.25 radian. Therefore, in degree beta will come out to be 128.7 degree. In the question statement, we have asked to find out the angle alpha, and this we can find out from the simple geometry. So, we have this drum and the weight is hang like this 100 kg, force P is acting like that. So, we have to find out this angle, and this angle we can easily find out because this angle is beta. Therefore, this angle will be beta minus 90 degree, and since this angle and this angle are 90 degree, therefore, this angle will be 180 minus beta minus 90 degree, which will be 270 minus beta. Therefore, this angle over here will be 180 minus 270 minus beta equal to beta minus 90 degree, and this is the angle that we want to find out. So, therefore, angle alpha will be beta minus 90 degree, and therefore, it will be 38.7 degree. With this, let me stop here. See you in the next class. Thank you.